Like everyone speaks about the MVP, the minimal viable product. But what people sometimes forget is the V. It has to be viable. And it has to be viable from a security perspective too. Like if I'm doing an MVP and my MVP is exposing credit card information, that's not an MVP. It's not viable from a security perspective.
Hello, everyone. Thanks for joining us in today's episode of XgridTalks, which is essentially talking about observability in Kubernetes environment and how it leads to security and reliability. My name is Abdullah. I'm the CTO at Xgrid based in California, and I run the cloud business group. A bit about myself, I have primarily a software engineering background and distributed systems background, and I've worked in Silicon Valley startups, Fortune 500s, and most recently I was at Salesforce, leading teams in the infrastructural space where we build software services for our cloud offerings in the areas of network security and threats and vulnerability management. A bit about Xgrid. So at Xgrid, we work with Fortune 500 companies and other customers in the areas of fintech, retail, supply chain, logistics. And we strongly believe that observability leads to reliability and security. And that is a common theme among our customers that we work with, that these two things are their top requirements as well. And there are a bunch of different substrates that people and our customers deploy their applications on, and we help them build their solutions, including Kubernetes, AWS, GCP. Today, we want to talk about a bit more deeply on the Kubernetes side of the things. And to talk a bit more on that, today our guest here is Nathan. Nathan is an influential blogger and speaker about all things Kubernetes. He's been writing code and working on open source projects for the past 15 years. Currently, he's the CEO of Robusta Dev. Robusta is an open source platform for multi-cluster Kubernetes monitoring, troubleshooting, and automation. So welcome to this episode, Nathan. We admire the work that you do at Robusta, and we really are excited to have you on board. So welcome.
Thank you. It's a pleasure to be here today.
So first of all, Nathan, when we talk about observability, right? So why do we really need an observability strategy? And what makes it harder to actually get it right in a complex environment like Kubernetes?
The problem is that there's a lot of moving parts. There's a lot of stuff that's happening. And when something goes wrong, you have to be able to really fast understand what went wrong and why in order to fix it. Because like it's easy to think about deployments and pods and clusters and all that. But at the end of the day, they're real world customers who are using our application. And you might be a Fortune 500 company, which has this service that has to be up. And when that goes down, like all the buzzwords, all the different stuff in the world doesn't matter. What matters is that you get that back up and running as fast as possible and you serve your customers, and that your business does what it has to do. And to make that happen, then it's important to first realize that something went wrong. And second, when something went wrong, it's important to understand why it went wrong. And the trouble is that both of those, both the first part where you realize something went wrong and the part where you realize why it went wrong, have become harder and harder over time as our systems get more and more complex. You'd think that like, as we get more technologically advanced and sophisticated, then everything like becomes easier to do, but sometimes it's the opposite way. Like a good example of this is our understanding of the world in physics has advanced tremendously in the past 100 years. We went from Newtonian mechanics to quantum mechanics. And when we got more sophisticated, things didn't get easier, they got a lot more complicated. So unfortunately, that's true sometimes in the cloud space as well.
Yeah, no, that's absolutely correct. I love the analogy there. So building a bit on top of the same thing, right? So we talked about these complex environments, and we know Kubernetes is a really complex environment with a lot of moving parts and things to sort of measure and look after. It quickly gets overwhelming. In your view, what are some of the sort of key metrics that you think in a production Kubernetes cluster that users should observe, and how?
So it's really useful to look sometimes at things from two perspectives. The first perspective is something wrong? And when you're asking if something is wrong, it's really useful to look at stuff in terms of SLAs and SLOs, service level objectives, and to look at not like, is internally like different stuff happening? Because maybe internally different weird stuff is happening, but nothing is wrong. A good example is, let's say you have a pod that's continually crashing, but Kubernetes is self-healing. It brings that pod back up. Maybe there's no impact from that. So you want to look at the high level picture of it. Like, is my customer getting what the customer expects? I have this service, customers can use it. And let's say I'm Uber and they can do food deliveries, right? So like, did the number of food deliveries remain constant in the past few minutes, or did it suddenly like drop? Now there are no more food deliveries in the entire world. Well, then something's wrong. So in terms of problem identification, it's very useful sometimes to look at that external perspective where people use SLOs, service level objectives, and using that and like related stuff, you can tell when something is wrong. But then once you know something is wrong, to troubleshoot that and to really observe that and to understand why it's happening, then sometimes you need a different set of tools that can let you drill down and understand why stuff is happening.
Yeah, thanks. So if I try to sort of break it down a bit, so what you're really trying to refer to here is that you have to contextualize sort of the environment and the things that you are running in, and see what really matters the most. So one sort of metric being observed at one place might not be sufficient in another contextualized environment.
100%. I mean, we're big believers in this because of what we do. And like, I did a lot of crazy things. Like I quit my job and like worked without a salary for a few months. And like, you do all sorts of crazy things, like, because I believe in that sentence you just stated, right? Like, ultimately the context is really important. So I'm like a huge believer in that. Also in the actions I've taken in my personal life and doing a startup around that. But the problem is when something goes wrong, the immediate piece of data that you're looking at is often not sufficient to understand why it went wrong. And there, the contextualization, taking something that went wrong, then adding on the context for why it went wrong is really important. If again, like you want to get your business back up and running, like you always have to remember at the end of the day, like you have that API that someone is calling to do food deliveries. And like, when that's down, well, like no one in the city of Seattle is getting food deliveries with Uber anymore, or like 10% of users aren't getting them and failing on that. So to get that back up and running as fast as possible, then you have to contextualize.
Yeah, no, thanks a lot for that answer. Just building on top, so we touched a bit about how complex Kubernetes environments can get. So what's a lot of the time when I talk to people when they're new with Kubernetes or they're trying to migrate and stuff like that. So there are some fundamental questions. One of the things that I always get is, okay, I know observability is important, all good, but when I'm running my application, do I need to worry about the Kubernetes infrastructure observability as well as my application or workload observability? So that's a bit of confusion. So what's your take on it? Do I need different strategies for infra and app observabilities?
I think it depends on what you mean by infra. So you definitely want to start by looking at the app. And you want to take an app-centric view of the world, meaning don't start with necessarily the pod, start with the high-level deployment. Like, okay, I have a deployment, I have a service. Is that functioning? Is that healthy? Is this microservice behaving the way it should behave? And then when you say infra, it could be like, there's almost two levels of infra. So the first level of infra is, okay, I have a problem with the pod. Now I just want to look at the node that's running on, or Kubernetes related stuff, or I'm looking at the deployment. I want to zoom into the pod. I want to zoom in now to the node that's running on. I want to understand what happened there. Sometimes you have to do that. It's almost an inevitable part of the way systems are built today. For example, if you have a pod that got killed with an kill, it ran out of memory, depending on why the kill happened, you sometimes do want to look at the node and understand if the problem is with the node, if the pod itself went over a limit, why that happened. So there, I would say when you gather that context and contextualize, then the infra details are part of that context. But then second layer of infra, and the deeper layer is like the Kubernetes control plane. And ideally, and we're close to this for the most part, you shouldn't have to look at the control plane and see like what's going on in kube system or what Kubernetes is doing. That should already be handled by whoever's managing Kubernetes for you if you want to manage Kubernetes service.
Got it. So diving a bit deep into a bit of this as well, right? So we've worked with customers who use, let's say, managed services, for example, AWS EKS, right? And they are just, you touched upon this, that you might have to see the context between how different layers of infrastructure that you might have to pull in, maybe not the kube system level, but a bit above, which is actually orchestrating the pods. On cloud environments, for example, on EKS, people ask us, okay, do I need to use container insights? Do I need to integrate all the Kubernetes controller logs with CloudWatch? Do I have to have events on them? There's just general, some of these things. If you touch a bit upon that, like what's your take on that?
I think there's a challenge with a lot of the traditional tools, which is that they work fundamentally based on tags and correlations. And I'll give an example to make that really concrete. So I have a pod that's running. That pod is part of a deployment, and that pod is running on some nodes, and it emits a log line. So that log line now shows up in CloudWatch. And if everything was set up properly, then that log line has like a few tags on it. And you can now take those tags and you can use those tags to like get back to the pod or to get back to the deployment. And maybe you don't know data about the node, but like once you get to the pod, and you can like try and again correlate stuff with the node. That's a process that a human can do, but you as a human have to do that contextualization manually. The problem is that if you look at like from CloudWatch's perspective, CloudWatch doesn't know anything about Kubernetes. CloudWatch doesn't know anything about pods, anything about deployments, anything about nodes. CloudWatch has a log line, and that log line has a bunch of tags. And those tags happen to have like pod equals XYZ. And a lot of the traditional systems are not built with enough, with an actual semantic understanding. This is a pod, it's part of a deployment, it's running on a node. This is the context that matters. So when people then try and investigate, then you end up like copy pasting different labels, and you try and look at something in a different system that happened at the same time and pulling together all these different disparate data sources. And that can be very challenging. Whereas the alternative approach and the way that you can do that is based on entity mapping. So when you look at it from an entity mapping perspective, then there's a pod here, which is part of this deployment. It's connected to a certain service object, right, or a certain API. It's running on a certain node. This node has like these logs at this time. That's like a log type relationship. When you look at it from an entity map perspective, then it's very easy to take all the made systems and do that contextualization, which is very hard to do if you're just viewing everything as like arbitrary log lines that have arbitrary tags.
It's a bit more on the philosophical side of the things. So when we talk to people, they say, yes, we love all your tools, but we have so many tools. How do we actually use them? When they say the how, it is mostly about the human element, like the friction that, oh, I have yet another tool that I have to now use and learn and all that. And with this ever increasing landscape of complex systems and new tools coming up, do you have a take on how do you remove this organizational friction between different departments? How do you standardize stuff? Like, what's your take on that?
Okay, so there are two philosophical approaches to this, right? You were right when you said it's a philosophical question. So there's the traditional Linux approach, and the traditional Linux approach is one tool for each job. And you can do all sorts of awesome stuff if you have a bash pipeline where you do like cat, and then you pipeline to grep, and then you pipeline to cut, and you pipeline to head, and you pipeline to tail. And each of these tools is really good at doing one specific thing. It doesn't try and do everything. So that's one philosophical approach. And then the other approach is like the Windows approach. We're going to build one thing, it'll do everything for you, it'll do everything for everyone. And you can go both ways. You can take, for some stuff, you can take one tool and one stop. And for some other stuff, for some other companies choose to take a bunch of different vendors that work well together. It has to be like Linux, like the traditional Linux philosophy with Unix, where you can actually connect those tools in a coherent way. But they're okay taking Prometheus for metrics, but taking, let's say, Elasticsearch for dogs. So it's two philosophical approaches. You can go either way. But I think the challenge, this connects to what we said about contextualization, challenge is when you have all these different tools, it's not even about like the observability tools. You as a company probably are deploying MongoDB and Elasticsearch and Postgres, and you have microservices written in Java and in Python and Rust and C and C++ and all these other stuff out there. And the DevOps team has to worry about, or the SRE team, or the developers on call have to worry about all those different aspects, as well as their Spring Boot application and their Node.js server. So how do you take the increasingly complex and increasingly large number of stuff that you have to support, and still as one person have all the knowledge inside your head for how to handle it? And that's a real challenge. I think that's part of where technologies like runbook automation come into play, and that contextualization and the ability to deliver as a software experience the knowledge that you would look up on Stack Overflow. So when we speak about that contextualization, like something went wrong, how can we go and gather the context, maybe run like the exact commands you would run if you investigate this as a person and looked at Stack Overflow, and then translate that into insight for you that you as a human can consume that says, oh, what went wrong over here is XYZ. I just need to click this button to fix it. And that's kind of the concept of runbook automation, or this contextualization that's based on the exact scenario that went wrong.
Yeah, thank you for that. I think that really helped sort of bridge the gap between these philosophical choices. Just sort of turning the page here, I know we talked about observability in general and stuff. I really want to get into, as I said before as well, we admire Robusta. I would really like to get some insights from your own side itself as well. Like, what are some of the specific benefits that you get by using Robusta?
Yeah, so the two areas that we really see the most customers getting the most benefit from is one, when they have multi-cluster environments. Some of the traditional tools are good if you have like one cluster or a small number of clusters. Then when you're really acting at scale, they just weren't built for that. So that's one niche. It's almost, it's like I can speak about different verticals, or I can speak about like the horizontal capabilities, right? So now I'm speaking about a specific vertical for a specific type of customer. But those multi-cluster environments are somewhere that's very painful with a lot of the traditional tools. And think about it, like you have 3 different Prometheus instances or 500 Prometheus instances, each one in a different cluster. Then you have to be able to pull together all that data into the right place. So that's hard to do with traditional tools. So that's one area where we see a lot of value. And then the second is around the ability to really get you fast to the root cause and to get you to the why and to get you to the fix. Again, think back about that Uber service that goes down, or Uber Eats is down, and you want to just get back up and running, and you're paged in the middle of the night, you're on call and you get a page, and you open up your phone, you glance at PagerDuty, you want to see there's something that's actionable. You want to see there, okay, why did this happen? Like, where are the logs? And you don't want to have to now pull out your laptop and then jump to one system and then copy paste a pod name and then go into your logging system and paste that pod name in there and then look for the logs and then go and pull in the Kubernetes events with kubectl get events. If you do all that, then now you're 30 minutes into the incident, and only now you're starting to understand if you even should page someone else or how you should handle whether you need to escalate. So what we do, and what we're really good at doing, is making sure that when you get that alert in PagerDuty or in Ops Genie or in Slack or whatever system you choose, because like we try and meet you wherever you are, we're not trying to change your behavior. But when you get that message there, that it has the context, that it's done that contextualization, and then you know what the next step is, and it's really actionable. So that's like the horizontal benefit that we're trying to provide. And then that specific thing becomes like especially good if it's in a multi-cluster environment, because there the traditional tools are totally failing.
Yeah, so if I sort of try to break it down, that's essentially Robusta is acting on your behalf, like the first like the entity that's doing the first order of investigation and actually pinpointing the exact issue for you, so that you don't have to sift through all that crazy logs and events that these Kubernetes environments throw at you and just tell you what to do. That, in my mind, is something really, really valuable, that if you can contextualize and pinpoint. So thanks for that answer. Just building a bit on top of that, right? So we mentioned that reliability and security are 2 of the top things that people in these cloud environments or customers that they want to nail down. What's in your mind the correlation between observability and security? And I know that we talked about Robusta contextualizing events. Is there a security angle to it as well? Do you look at security events as well?
We get asked about it a lot. It's an area where today we're looking mostly to do work with our partners. And there are other companies that are maybe interested in providing some of that. But we ourselves are really, really focused as our core use case on observability. I did security. Me and my co-founder, we've done like cybersecurity startups for companies for over a decade now. And with Robusta, we're actually trying to focus really on that core DevOps use case. And there are live security use cases too. But like as a startup, you want to be really laser focused on which pain points you're going to solve and which pain points you're going to solve today, which pain points you're going to solve tomorrow. And for us, the pain that we see and the painkillers that we can bring to people in the DevOps space are big enough to occupy our attention for quite some time.
Okay, that sounds good. Just want to build on top of that, right? I know that we want to really focus on in terms of solving one problem, but as a tool, I'm asking this because this confusion is like permeated across multiple people that I talk to, right? Is give you an example of, for example, a cloud custodian, right? It's just like a sort of a stateless rule engine that allows you to filter resources and do stuff on it. People use it in different ways according to their own requirements. Some people use it purely for just cost saving. There are people who say that, oh, we provide the best solution for cost saving using cloud custodian. Some people look at security events for the same set of rules you can create. So similarly for Robusta, I know that you're focusing on that, but if someone wanted to natively integrate, let's say, security into observability, will we need something other than Robusta to do that?
We're open source. So like the best things always come with a PR attached. And we've heard a lot of interest around this. So like we have already the capabilities to take data in or to trigger automations and to do that contextualization if you trigger Robusta with a webhook. And we will work with, like as part of our community, we work with a lot of people who want to do different things, even when it's different than our core focus. So as an open source, you end up getting used in a lot of different ways that you don't always expect. And then if one of those ways ends up being like 30% of the people who are coming to you and talking to you, then you start to really look at that and say, okay, you know, this is interesting. Maybe I should prioritize this internally as well. So as an open source project, then you develop technology that can be used in a lot of different ways. And then you choose which of those ways you're going to put like your built-in in-house resources on. And then which of those ways you will ask people who want to do that, and you will provide them with the full support they need, but you're not necessarily going to have your whole company work on a sprint to support that or build out that capability. You're welcome a PR for it, of course, but you yourself are going to focus on something else primarily. So you need to balance the two of them there. And you want to balance on the one hand, really giving everyone who shows up in the community, like the full support they need to add out features that they want, that they're looking for and that are useful. And on the other hand, also as a startup with always like never enough resources to also stay focused on what's your core mission. So it's a challenge, like as an engineering leader and a product leader, that you have to balance.
Got it. And building on the same security concern, like when we build these complex things and we introduce these different components, right? With each introduction of each component, you're essentially also increasing your like risk area, right? Your surface area for attacks and all these things just gets like huge, right? Your blast radius and all that. And so maybe this is not as important for really early stage companies because they're just trying to prototype stuff and all that. But so the moment you move to mid to enterprise, where you have to deal with these SOC compliances or the PCI DSS or things like that, then you essentially really have to evaluate each component. With these different tools, let's just take an example, right? So for example, Prometheus or Robusta or maybe any other tool. Once we bring that into the environment, is there any inherent security concern that comes along with this? If yes, how do you mitigate that?
So it depends on the tool. I can speak about Robusta because it's what I know best. So we have companies that don't want to send any data to the SaaS platform, but they want to use the features of the SaaS platform. So we have a pure open source offering, which obviously like is just in your cluster. And then we have a SaaS offering where you can send data to the SaaS platform, like get a single pane of glass into all your clusters. And it's built that way because like fundamentally, if you want to provide a single point of view into all these different clusters, into 500 clusters, then you like don't want to be running in one of those clusters, right? You want to be running in a third-party location. So we have customers who say, I really want this, but I can't send data to your cloud. It's not an option. So for those customers, you have to offer, either you offer an on-prem version, which we do, or you decide that's not something I'm going to focus on, and I'm going to tell those customers to go elsewhere. So like in our case, we've chosen to support that and to build it out. But you have to understand that there's a trade-off in terms of engineering resources. like when we were at a decision point 6 months ago where we got the first inquiries about running that SaaS platform on-prem, and we had to make a hard engineering decision. It's like you say about that trade-off, like live early stage startups don't care about security. Well, if you don't care about security, you're not going to have Fortune 500 companies. You're not going to have Fortune 500 customers. So you have a trade-off to make. Do you want to have at the current stage those Fortune 500 companies? And is it realistic for you, given your current resources, to support them or not? And then there are different paths you can take. So you could say, I'm going to run everything on my own cloud, but I'm going to do SOC 2 compliance. And is that enough to actually like satisfy the security concerns there? Or you can say, I'm going to do on-prem, so it'll all be running in the air-gapped environment anyway. So then that like reduces the attack surface. And is that enough for those customers? You can approach it differently. Or you can say, I'd love to have you, I'd love for this company to use our product, but we can't do it right now. And we're not going to support that use case. So you have to make hard decisions there. And you don't always know whether that decision is right until like 6 months later. So that's a hard decision to make as a product leader. And like when you're planning out your roadmap, but I think you are right. There's like a fundamental trade-off when you're building these products. Like you have to understand the end user will take security into account when evaluating you. And you have to decide what security requirements you're going to satisfy and understand that it's a trade-off between engineering resources and not getting to implement other features and being able to provide the level of security that these large companies want.
Makes sense. Stretching on this, right? So we talked about different companies and different use cases. Some of the use cases that we come across are, so they're nascent, but people are trying to go into those where they want to stretch their applications across different substrates. When I say different substrates, they will have like some of the people we talked to said that, yeah, we want our control plane to be on-prem, but some of the workloads can be on the cloud. So that's sort of now inherently introduces another network layer as well in the middle. I know there are abstractions that can sort of manage these things for you, but for a plain user or a customer who's trying to make that decision that if I have multi-cloud environments or hybrid environments, will it add more to my cost to have observability across these environments? Or will a one-size solution sort of fit all, which we already said might not. But what's your take on these geographically distributed environments, if I must say?
We charged, when you bought our like enterprise plans, we early on charged based on the number of clusters. And we walked it back because we got a lot of pushback on that. We saw people, like it wasn't fair to the customers because sometimes you'd have customers who would have like 100 clusters, but each cluster would have like 3 nodes in it. And then you'd end up charging them more than another company that has like 1,000 nodes, but it's only in one massive cluster. So like, I think you shouldn't, like, I think both deployment models, like in the number of clusters you have and all of that, are valid architectural choices. And there are real good reasons why you would choose to go with one way or another. Hopefully that doesn't impact your choice of observability tools just based on building that like on cookie cutter building that doesn't take your needs into account. And I do want to add on something just also about this. I'm what you would call a Kubernetes maximalist. So I believe that Kubernetes, for various reasons, that Kubernetes or something very similar to Kubernetes is the future. And increasingly, I think the choice that you have to make is, am I building applications that run on the distributed operating system known as Kubernetes, or am I building applications that run without something else? And if you go back to like the early days of Windows, like you have to decide, am I writing something that runs on like on a microprocessor, application that runs on a microprocessor without an operating system, or am I writing an application that will run on Windows or Unix or whatever, and then I can run it on any hardware? So the hardware here is either on-prem, or the hardware is like AWS, or the hardware is GKE. The hardware might be a different Kubernetes data center in different places. If you're targeting the operating system that's Kubernetes, the distributed operating system that's Kubernetes, then you have a lot more flexibility. I'll give an interesting point here, something unusual that people don't usually think about. recently in Azure this past week, they ran out of, I think it was they ran out of instances of a certain type. They had there was an issue, I guess, with the capacity planning, and they did this past quarter. And I don't remember if it was instances or IPs, but I think it was instances. They literally ran out of instances in their data center, because it's nice to think we're running in the cloud and it's up there, but no, really it's someone's data center and there are server racks, and they do capacity planning and they build out the right number of servers, and they have trucks that bring in those servers, and they hook up the automated fire extinguishers, and there's a shortage in the physical data center in a certain location. So maybe you chose to run on that specific hardware, which in this case is AKS. But if the hardware isn't there, you're going to want the ability and the flexibility to take another machine somewhere else. And if it's running that same operating system called Kubernetes, then it's all good. Your application runs on Kubernetes. It doesn't matter which Kubernetes, where it is.
That's a great example. I think people would really relate with that. Okay, so building a bit on, I know we touched a bit about the time to market for early stage companies, etc. But in my mind as well, security and observability can't be afterthoughts. But I also get the point when I talk to people yeah, right now we're just prototyping, we just want to go to market as quickly as possible. Specifically for Kubernetes environments, are there any pitfalls where you say that, oh, okay, I'm going to implement observability 1 year down the road, maybe, right? What's your take on that?
There's scenarios where it makes sense. I mean, I'm a realist at the end of the day. I'm pragmatic, right? So if you have an application and it's running in production, and you're a year away from even having customers accessing that application in production. Right now, it's just internal dev teams. And if something crashes and goes down, there's no impact whatsoever, then yeah, I wouldn't invest that in building out observability for that. I would invest in the developer experience. How fast can developers do code changes? Or how fast are they working? What's their iteration cycle like? I would look at tools there, like Octeto, for example. I would try and look at different stuff in that space. I wouldn't really focus too hard on building out the perfect observability system for something that's not even running in production yet. So it doesn't always make sense. But I think one thing that also now speaking from my hat as a co-founder, everyone speaks about the MVP, the minimal viable product. But what people sometimes forget is the V. It has to be viable. And it has to be viable from a security perspective too. If I'm doing an MVP and my MVP is exposing credit card information, that's not an MVP. It's not viable from a security perspective. So when you take viability into account, and when you build that MVP out, you have to make sure it's viable. Now, what viability means differs depending on the stage. So at some stages, it's viable without having that observability. If it's processing no real production data yet, and there's no customer data on there, then maybe in terms of security, there's a little more leeway in terms of viability. And if no enterprises are using it, then you probably don't need an OAuth integration. But it really depends on where you're at. But it does have to be viable from a security perspective and from an observability perspective as well.
That's a really cool way to look at it. I like the analogy in terms of the viable, different, and I think it all comes down to the takeaway, the contextualization, right? So you have to contextualize where you are in your journey, and depending on what that V means in terms of that, you have to implement the right sort of tools. I've still seen cases where people, yeah, you rightly pointed out, where sometimes there are some sort of you overlook some of the viabilities in terms of the security, and then there's this technical debt that you incur. Something bad happens, and then everyone just wants to do security, and at that point, it's a bit hard, and it's a lot more friction to implement those things. But yeah, it makes sense that you contextualize how you move along. So Nathan, I think this has been a really useful session. I just have one more question where I want to just end this. So I know we've been talking about the core details and underlying the infrastructure and application and observability. I just want to move for our listeners and watchers just a bit at a higher level as well, right? So I know we talk about these different market segments, like so retail, fintech, e-commerce, supply chain logistics. All of these have different substrates, and increasingly we see Kubernetes being adopted for some of these use cases, but there is still a large chunk that just runs on-prem or on cloud and all these things. Overall, if we just talk about the Kubernetes side of the things, do you envision a Robusta playing a part in sort of making a specific industry really, really like rock solid? Is that something that you think about?
Yeah, it's interesting. We don't currently focus on one industry as much as we focus on the characteristics of your environment. So if you have a large multi-cluster environment, and you'll know if you have a lot of clusters, like then that's in like a segment that we want to be the best in class at, and we're doing a pretty good job at. Or for companies that have a certain number of employees, we'll say, okay, we want to be the best there. We want to get that those companies get farther with the number of employees that they have. So we don't focus on the industry in terms of a specific vertical, but we focus on what your company and what your infrastructure looks like when we decide where we want to be best in class today, and then where we want to be best in class tomorrow.
Sounds good. So that's really the sort of end of the session that we have today here. It was really an insightful session. Thanks a lot for joining us, Nathan. I'm sure the audience has a lot to take in and learn about Kubernetes, and definitely I would say people to look at all these different tools and look at Robusta and see how they are contextualizing things. And it goes back to the point that Nathan had. No matter your environment or your application or your use case, you really have to contextualize the right amount of things that you want to put in your application to get to that MVP stage. And that MVP is going to be different across different things. So once again, thanks a lot, Nathan. We really enjoyed having you here. Any last words that you want to say, and we can just take it from there.
So one thing that we get asked about a lot is, why do I need XYZ in Kubernetes? Or why, like, is Kubernetes really worth the complexity, right? So I think what separates good engineers from incredible engineers is that the incredible engineers don't just know how to use something, they understand why it was built that way, and they understand the engineering trade-offs that went into something. I take an example, like, why do you even need pods in Kubernetes, right? Like, it seems so obvious, right? We have pods, but like, why couldn't you replace every instance of a pod just with a container? What would you lose in the world if you did that? So one thing that, a new initiative that we're starting is we're starting a new newsletter on Substack that's really to help engineering leaders and engineers like acquire that knowledge, which isn't always so obvious, about the trade-offs that went into building Kubernetes itself and like why it's built the way it is. So if I can plug that, then that's something new that we're launching tomorrow. And the first episode will be about why Kubernetes even has pods to begin with. And we're going to call it Why This Kubernetes Thing. So I hope that's something that will be useful. And I would encourage listeners to reach out and send us your questions so that we can really try and prioritize the topics that we speak about.
That's perfect. So everyone, you listen to the man, right? Send your questions to Nathan, and we would definitely link the new newsletter that Nathan is talking about under this podcast and talk once we publish it. That's all, folks, that we have for today. Once again, I'd like to thank our guest Nathan for taking his time to join us, and I look forward to more such sessions, and more power to Robusta. We admire you, and we will keep cheering for you. Thank you so much for your time.
The pleasure is mine. Thank you.